I'm going to provide a brief overview of the status of developing the Great Barrier Reef Climate Change Resilience Index. We began this process by producing a vision for the GBR Climate Change Resilience Index in early 2012. We gathered in Brisbane and we talked about aligning the Climate Resilience Index with existing reef reporting like the Outlook report and of course the Queensland and National reporting. We developed a pathway to developing this resilience index. We started with creating a conceptual framework, which I'll brief you on, and then developed a plan to conduct desktop analyses, develop some indicator thresholds, testing those in field experiments, and then being able to calculate and disseminate results using a broad communication strategy. So the conceptual framework that was initiated was this one of a cross-section of the reef with a variety of different habitats, mangrove, seagrass, and corals, and then climate impacts, climate adaptation, and climate mitigation. And so major impacts on mangroves include the sea level rise that causes inundation, with seagrasses turbidity, which reduces the light available to support its photosynthesis, and then for corals, the temperature and acidity that impacts their growth. And then for adaptation strategies, allowing upward migration of mangroves, maintaining water clarity in particular for seagrasses, and for corals, improving the water quality and reducing crown of thorns to maintain a healthy reef that can bounce back after a bleaching event. For mitigation across the board, reducing greenhouse gases is essential to reduce these increasing temperatures, increasing acidity, increasing sea level. So greenhouse gases have already been shown to increase the global temperature, sea surface temperatures as well. The CO2 that's been tracking upwards in Hawaii has also led to ocean acidification. So these aren't projections, these are measured physical factors that have occurred over the last century. Now, we're also seeing that these strong signals through El Nino in the Great Barrier Reef cause moderate to severe bleaching. So the increasing frequency of this is shown on this graph, and a bleached and unbleached reef is starkly compared in these two photographs. With mangroves, in addition to inundation and sea level rise, the rainfall changes affect their distribution, and you can see on a graph of Queensland mangroves that annual rainfall influences the wetland cover. So in very dry areas, these trees don't thrive. Temperature is also implicated with seagrass decline. You can see the photosynthetic efficiency dramatically drops above 40 degrees C. And in the shallow water tide pools for the intertidal seagrasses, this is not an unusual temperature to occur, and so punctuated events with high temperatures can burn seagrasses out. Rainfall and runoff variability increase with climate change, and again, this is Janet Luff has not looked at the forward projection, but just analyzed historical trends, and we can see the variability in the rainfall is increasing, so it gets wetter and drier. So, we're talking about droughts punctuated by extreme events. Of course, these extreme events on the map on the right lead to pulses of runoff, and these flood plumes that you see here, colored in brown, influence the inshore reefs in particular all throughout the Great Barrier Reef. And remember that this isn't just sediment and fresh water, but it's also nutrients and toxicants that come rushing into those inshore reefal systems. So taking stock at the GBR level, looking at 6 different reporting regions, which correspond to the regions used in the Great Barrier Reef Report Card: Cape York, Wet Tropics, Burdekin, Mackay, Whitsunday, Fitzroy, Burnett, and Mary. I think I forgot the Burdekin in there. And so what we took is a qualitative assessment of the kinds of reef resilient patterns that we might find when we properly analyze the data. And we suspect that Cape York is going to be the most resilient, and then the southern reef regions the least resilient, and the wet tropics somewhere in between. And now, almost 2 years later from that initial scoping, we've got various climate resilience projects that are underway in the Great Barrier Reef. We've had 3 iterations of the Great Barrier Reef Report Card. And meanwhile, over here in America, the Integration Application Network team is developing a Chesapeake Bay Climate Resilience Index. And next week, we'll gather in Townsville to continue the development of this Climate Change Resilience Index for the Great Barrier Reef. Thanks.